Hey everybody watching from home, welcome to Discovery from Afar. I'm Lennon and you're here with the Lennon Stand. And today we're going to be going through a couple different experiments, all water-based. Now, to join in at home today, we're only going to need a couple things. We're going to need a large tub of water, a small cup, something that we want to keep dry, and for our second experiment, we'll need that same tub of water, a small cup, and then some postcards. And then from our third experiment is our final pizzazz. We're going to need a 1 litre bottle, a ballpoint head. Even if it has a hole in it, we can simply solve that. And then a couple of little weights to keep our ballpoint head down in the ground. So, to begin our science show for today, and to welcome you all to the Lennon Stand, I'd like to introduce you to this previous bottle of water. Now, for this experiment, I'd like to get everybody to watch very closely as I'll put our piece of paper inside our cup, and we're going to ask ourselves what's going to happen when I put our cup inside the water. It's a bit of a tricky one. Will it get wet? I think there's a little bit at the bottom will. Maybe the water will flow all the way up into it. Or maybe it may just stay dry for some mysterious reason. All right, so I'll put it down in 3, 2, 1. Oh, it's gonna overflow. It's overflowing. Oh, but look at that. Did you see the bubble come up? Oh, there's another bubble. So something's going on here, and our piece of paper is completely dry. Lucky it's still dry, and I can use it to clean my hands. It's no longer wet now. So what exactly was happening then is that as we captured our piece of paper inside our cup, we had a large pocket of air inside of it that as we put down the cup, the air was still trapped inside of the cup and was staying there inside of it. Our piece of paper was inside this air pocket, keeping it nice and dry. But as I tilt the cup, we can see big bubbles fly up to the surface, and that's the air bubbles inside the cup escaping. Now, this would work even if we were under the ocean and had a boat in front of us, just like a Jack Sparrow skit as they're walking deep under the ocean. Or maybe if we got too deep and we tried to do this with our cup, the water would have enough force to push up through the air and start to wet our piece of paper. So that is our very first experiment for today. The second experiment, we're going to fill up this cup with water, and we're going to hopefully not get very wet. Now, if I can accurately pour the water inside this cup. Now for this one, we're going to bring our piece of paper on top of it. Now, I'm going to turn this cup upside down with a piece of paper, the hard bit of card paper on top of it, and I'm going to turn it upside down. Now it's up to you to think about what's exactly going to happen next. Is the water going to flow through the cardboard? Is the cardboard going to maybe catch it there? Or is it just going to become soggy cardboard and drench everything here? So, for this, I'm going to hold my hand very firmly on top. You can easily do this at home as well. I'm going to hold the cup here at the bottom, and I'm going to very quickly turn it upside down in 3, 2, 1. All right, so there's no water. And the bit of cardboard is there stuck still. I'm confident enough that I can have this above my head with nothing bad happening at all, except that it's slipping. So, this cardboard is actually surprisingly well stuck, where even if I warm my hands around a whole bunch, it's stuck really well. Now, what happened then was as our cup captured all the bit of water and our piece of paper was sitting on the bottom of it, as we turned our cup upside down, there was a very slight amount of air that escaped then. This air didn't have any air rush in to fill it up. It actually created a vacuum inside our piece of cup, holding our cardboard very strongly stuck on the bottom of our cup. So what we created then was a slight little vacuum inside of our cup. Now that's quite an easy experiment to do at home. If we have a hard bit of card paper that's now very soggy, we have to make sure it's very dry and very flat. And we just need to fill our cup full of water. And then we can see if we can wet our trusted adults by pouring our cup of water over top of them. So for our last experiment for today we'll be making some bottle scuba divers. In here I have a bottle, a 1 litre bottle that's filled to the very brim, so much so that there's barely any water escaping at all. And what we can do is we can make our bottle cap inside of this go all the way down and all the way back up, looking exactly like a scuba diver. So as we squeeze it, he dives all the way down, and then comes swimming all the way back to the top. Surely one more time so we can see exactly what's happening there. We squeeze it, doesn't look like I'm squeezing very hard, and then it swims all the way back up to the top. So, in a moment, I'm going to show you exactly how to make this. But first, I'm going to need to empty our water bottle here and show you the little machine that I have inside of it. So what we have here is simply a full bottle, 1 litre of water, and our little swimmer buddy, as we make water all over the place, is a pen lid that has a little bit of blue tack around the top of it and has our paper clips hanging from the bottom of it that are tied up by a rubber band. To make this, we're just going to need to put a bit of blue tack over the top of it. That's only because my bottle cap, my pen cap, actually had a hole in it. So I had to make sure this hole was in it so we'd capture air inside of it. And then we are to get a little bit of a rubber band, and we're going to put all of our little paper clips inside of our rubber band so we can wrap them around very tightly. So just as I have here, we're going to thread a rubber band through the end of it. Clearly I don't have a very steady hand, but I do my best. Now, we're going to try to twist this up as much as we can, and we're going to look to attach this to the bottom of our bottle cap. Now, we can do this in any way we find out how, whether it be with a bit of tape, a bit of glue, or even rubber bands as I have here. Now sometimes our rubber bands are actually done properly and aren't broken, so it makes it a lot easier to be able to fix them together. So as I continue to try to wrap our rubber band around it properly, we were looking to fix rubber bands to the bottom of it. Luckily, I have another solution. Instead, I'm going to use some blue tack, as I've used for the top of it, so I had plenty of blue tack lying around. And I'm going to attach our 3 paper clips onto the bottom of our little scuba diver by simply just forcing the end of the pen lid into our blue tack clump. Now, what's very specific about this is that we have to make sure that this is what we call neutrally buoyant. So it floats only ever so gently. So as I put the water inside, as I put the bottle cap inside of it, we can see that we have a little bit too much weight on it because it goes down to the bottom. Sometimes it will float too well, as then it will float right back up to the surface. So to remove the weight of it, I've just ripped off a whole bunch of blue tack, and I'm going to try again. So once again, it went all the way back down to the bottom. We're going to remove a bit more blue tack so we can hopefully make it neutrally buoyant. So we don't have to use exactly bottle caps for this. We can cut straws in half and fold them over and attach little paper clips to the end of them. Or maybe we could find other floating materials, like even if we use little chocolate candies, they float exactly how we want them to. So we'll try one more time. I've got off a lot less blue tack, and we're going to put it in. Now, it's still sinking down to the bottom, so I'm going to try this one more time. Or, I like to say one more time, even when I mean many more times. I'm very stubborn when it comes to making sure our bottle caps work properly. And the intention with this is to show us something quite amazing about why things float. So we have here, when I've finally removed enough blue tack, that it just floats above the surface. Below the surface, mind you, sorry. So now we're going to want to fill. Now we have our scuba diver ready. If I wanted to, I could cut up little pictures and put a little bit of a scuba diver picture on top of our bottle cap. But today, we're just going to be happy with how our Mr. Bottle Cap looks, and we're going to fill up our bottle with water. Now, I'm going to do this out of the way of the camera, because we're just going to fill our bottle up to as much as we can. Then we're going to top off it a little bit with one of our cups just here. So 1 second, as I tuck over to the sink behind me, and I fill up our bottle. Now our bottle is all the way full. So full that it's almost overflowing, as I'm not sure if you can see with the camera. If I squeeze it a little bit, the water will come up out of the top and keep flowing out. So what we're going to do now is we're going to grab a little bit of water from our large water container here. And we're going to top it up to the very top, so it almost looks like it's overflowing. The water sort of reaches the very top of the bottle and actually creates a little lip over the top of it. This has a very special name to it. It's called a meniscus, but we don't worry about the naming of it today. So now that we have our scuba diver inside of our bottle, we're going to bring our bottle cap to the top of it, and we're going to seal it up nice and tight. And we're going to squeeze our bottle and watch as our scuba diver goes down, and then he slowly swims back up to the surface as we release it. Then we're going to squeeze again, and our scuba diver dives all the way down again. So what is actually happening here is that water is what we call an incompressible liquid. So if I try to force water down as much as I could with my own hands, like we do a spring, storing all of the energy we can into it, water will not actually shrink in size because of it, unless we have an extreme amount of force, like a whole ocean load above it. What instead, when we squeeze it, since the water's not being shrunk, is the air inside our bottle cap is being shrunk. So by the laws of flotation, we have things that are more dense than water will float, on water that is. So when we squeeze our bottle cap, we are actually compressing the air inside of our pen lid, and we then make the pen a little less dense to then send our diver deep down into the depths of our bottle as he then swims all the way back up to the surface. So this then concludes our show today. I hope we've all had a lot of fun learning about maybe what we could make at home, what we can make a mess with, and what then we could maybe drown our friends and parents with when we next see them. Either way, I'm glad that today we can learn a bit about science. I hope we've all had a fantastic time, and I hope to see you all again next time at the Lennon Stand. Thank you.